Okay, guys, I will start the class for now. Okay, so where did we left for the previous class? I gave you some task, right, to derive some Boolean expression for 4 is to 1 marks. Did you guys any found out how to derive that equation? Okay, look here, I will explain this. Okay, see here, how to derive this Boolean equation. Okay, this Boolean equation can be derived easily. Like if you guys know the truth table means we can write this equation in a easy method. Okay, see here, look at the truth table. For 4 is to 1 mux, we have two select line, right? And four input and one output, right? So based on these select lines, we are going to decide which output, so sorry, what output should be, right? Based on these select lines, we should define what should be the output. So look here, for select line 0, okay? If for select line 1 and select line 0, right? So there will be two select lines. You can be named as select line 0 and select line 1. Okay. If the both select line is 0, then we will get output IO, I0. Okay. If the select line 1 is 0 and select line 0 is 1, then we will get in output as I1, input 1. Okay. How you are going to remember this? Using memory trick called binary values. Okay, what is the binary value of 0 0? It will be 0 0 1 1, right? Like that only. For 1 0 2 and 1 1 3, right? It will be the binary value. Like that only you can derive the value. See, using, see, look at this equation. Okay, what I have mentioned, s1 and operation, s0 and operation, I0. Okay, this dot means and operation. Okay, so if you and this everything, okay, then what will be the output you are going to get? If s1 means, look here, s1 is 0, right, for first one, and s0 is 0, right? So we have here one dash, right, that is called as inverter symbol, means not gate. Okay, we are applying not gate here. For s1 of not becomes, first it will be 0, right, then it will become 1. So like that only. For s0, it has not operation, so s0 becomes 1. And operation of 1 is, both and operation of 1 is 1, right? So 1 with any input value, IO means it will be true, right? So input 1 is passing, okay, input 0 is passing, so it will become true. Okay, when this condition becomes true, this input also, input I0 also become true, right? So and operation of 1 with any input becomes 1, right? So this will become, so then y will become I0. Okay, so wait, I will show you note that. We know something like this, right? If s1 is equal to 0, then y is equal to a, right? We know something like this, right? This is usually used for mux, right? 2 is to 1 mux. Like that only. See here. Now we have select line S1, S0. Both are true, right? So AND operation of both will become 1. So then any AND operation with input value. So think I1 is passing, I0 is passing, okay? So if I0 is passing, then it passing means true, right? So I0 is equal to become 1, right? Then uh, so S1 AND operation with S0 will becomes 1. So that AND operation with I0 becomes 1. So now for both S1 and S0 is true, what will be, I0 will become 1, right? So then what is the equation y will get as y is equal to I0? For try for other example. So 0 1. Okay, what is the not operation of S1 here? 1, right? And now S0 is 1, right? For second step, S 0 of AND operation will become 1, sorry 0, not operation will become 0, right? So while AND operating, one value is 1 and another value is 0. So does AND operator give any values if the both values are different, like 0 1? No, right? So the what is the truth table say of AND operator? Both the input should be 1, right? So here we have 1 0 and 1 1. Okay, so then AND operation of these two combination will become 0. So like you are doing a of AND operation with any other input, so 0 with input becomes false. Okay, then I0 is not passing. So next check for like that only, same combination 0 1. Okay, what will be the not operation of S1? S1 is 0. Okay, S1 is 0, so not operation becomes 1. Then S0 doesn't have not operation. Okay, then it will become 1, right? Or it will remain same as 1. Okay, now look here, S1 is 0, so not operation convert it into 1. So now S0 is 1. Okay, so AND operation of both inputs are 1 1. So the AND operation will become true 1. So while you are operating with an input I1, okay, it will become true. So now you are getting y is equal to I1. So just like try like that only, same step for 0 1 only. S1 will become 0, S0 is 1. But here we have not operation, right? Not operation means it convert 1 to 0. For AND operation both inputs are 0 here. What will be AND operation will become? It gives 0, right? So 0 with any input will become false. So y doesn't have I2. Now just like try that only, 0 1. So AND operation of 0 1 becomes 0. So 0 with any other input, it will become false. So now for the step 0 1, what is going to pass? I1, like I1, right? Like this only the how the Boolean equation works. So like this only you need to calculate for I2, sorry, 8 is to 1 mux also. Okay, so look here, how to write this short and Verilog style. Okay, how does it work? Think here. Okay, select line 1, select line 1. If what does this question mark says? If question mark says if select line 1 is true, then go check select line. If it becomes true, check this line. Okay, select line of 0 question mark I3 is to I1. Okay, if select line 1 is 1, then it will check here, or else it will go here. Okay, like the this how it works. Okay, so come here, try to we can try to solve it. Okay, if first condition what we have, select line for first two table, select line is 0. Okay, so select line 1 is 0. So the condition become false. If the condition become false means it's go for second equation. Okay, this equation. Okay, here what is now we have for truth table, first truth table 0, right? So select 0 is also 0. So it will become false. So it become false means what is going to do? It's going to I0, right? because it is the second condition for select of 0 here, right? False means second condition, true means first condition. Okay, so now what does the y value as I0, like that only check for this. Now select line 1 is false. False means it goes to this line. Okay, so here now we have select line 0 as 1, so it's check the ternary of a condition. Okay, so we have now select line 0 as 1 value, so it's true. So if it becomes true means it will go to I1. See, right? That's how this condition works. So based on this truth table, you should able to derive these conditions. Okay, okay. If you solve that condition using this truth table, you need to get the output same as in the truth table for here for y. Okay, you should always design like that only. Okay, based on truth table, you need to design that equations. I hope everyone got to know how to solve this kind of equations, right? So we were stopped at the assign statement, right? Using assign. So in a previous case, I mentioned about this 1 is to 0 select line lines. So this means select line as 2-bit data. 2-bit data means select 1, select 0. Okay, you see here. Here in wire, you can also write input is in the same form. How means, look here. You can also write in the same form for input also. Input wire, how many inputs we have? We have four inputs, right? So 3 is to 0. This will create inputs from where 0 to 3. Like, so if you mention like this, then this will create input from 0 to 3. Okay, input 0, input 1, input 2, input 3, like that. Okay, it will create like that. Okay, so what you are mentioning, right? It defines the bit select lines, like how many bits input you have, how many bits select lines are there. Okay, so this is the form of writing, like rather than writing select 1, select 2, or I0, I1, I2, I3, you can keep it short like that. Okay, so look here. In previous class I was not mentioning like wire reg in design code, right? So we were only mentioning that in test bench code. Okay, so how come we are now using here wire and reg here in the design code? Did anyone get doubt on this? So look here, I will explain why we are using wire means. So if you write a design code, okay, if you just mention like this, input, think I1, okay, I0, okay, like this you are mentioning in previous. Okay, or input A, like this you are mentioning in while writing a code for a design, right? So by default in verilog, irrespective of what you are mentioning, like input A, input B, output Y, by default it has wire. Okay, by default it has wire. Okay, it doesn't have reg. So if you need anything other than wire, you should mention, like if you need reg means you need to mention reg. Okay, so by default it has wire. Okay, if even if you don't if you write like this also, it means input wire A. Okay, so just to like make code to look easier or to read easier, we are going to write wire there. Okay, so yeah, we have mentioned output reg as y, right? Why? Because Look here, I will explain this reg when we're going to write a test bench code. Okay, so you will just think why, just answer me why reg is used. Reg is used to store a memory, right? Okay, it uses to store a element. Okay, so just think why needs to store element. That's why we are using reg. And here we have always at begin block, right? What is going to create? This is going to create a procedural block. Okay, so when you use always at the rate asterisk, you need to mention, or you need to use reg. Okay, for output. For output you should always use reg. Okay, just don't miss this reg while you are using always at begin block. Okay, so now you are using if else. Okay, if else how it works. First it selects for select equals to 2 bit 0. 2 bit 0 means here first 0 is s0 and second 0 is s1. Okay, so here you're mentioning like 1 is to 0, right? So what does 1 is to 0 means? 2 bit line. If you mention 2 is to 0, then a 3 bit line, like that how it works. So here now you have 2 bit code. Okay, 2 bit code in which both select lines. What this double zero mentioning? This double zero is mentioning that both select line are in off state. Okay, so when both the select line are in off state, what will be the y value? Y is going to get I0. Like that only if else. If select line is 2 bit 01, okay, 2 bit 01 means S0 is in on state. S0 in on state. So you are going to get output as Y1. Okay, because 01 is the binary value. Okay, of I1, right? Like that only if else if select line equals to 2 bit 10. 10 means we are going to get output as 1 2. See here truth table. For 10, what are you going to get? For 10, what are you going to get? I2, right? Like that only for you need to write the code. Okay, so else before like you can also use else if here at last. Okay, else if select equals to 2 bit 11, y is equal to 3. You can use like that also, but just to like pass the else statement. Okay, if you don't get any of this output, then it should in if you don't use this any of this condition for true come to true means at least you need to use this, right? So is now my screen is visible? Is hello guys, is okay, thanks. Yeah, we can continue, right? See here. So to end the statement, like if nothing works, at least you need to use this statement, right? So purpose of using, like, if nothing this three statement works, at least we need to pass this limit block. So you are using else. Other than you then this, you can also use else if statement, okay, for the past statement. So like this, always creating a begin block, you need to end that, right, end that design, and you need to end that hardware block using end module. Like this you are going to design using if else. When it's come to case, okay, same thing for creating a module. So you need to mention range, because you are using always block in design code. And you also mention case, and basis on what you are going to select the input, okay, basis on select we are going to produce the output, right? So select means this, you are seeing here 2 bit 00, right? This will be the select values, okay, case. How to read it? Case 2 bit 00. If a case is equal to 2 bit 00, okay, if select lines is equal to 2 bit 00, then you are going to produce output as I0, like that only. Basis on the truth table you are going to mention like this only, okay. So default, if nothing works, then it's going to create a 1 is equal to 1 bit bx, okay. Bx means while you write this code means you will get like y is equal to, in some waveform you will get like in red line like x, okay. If you mention this, okay, if something wrong happens in your circuit, so to see what's going wrong in there, like in waveform it will show like uh, in red line x mark, okay. So that is called as this default case is called as safety net, okay. Unknown value has occurred. So you can say that, oh, something is passing there as an input, so our code has broken, okay. So just to make sure that where is our error, like what is our error and why is the error is coming, uh, to check that you are going to give a default case by using case statement, okay. So this is how you are going to design an end case using 4:1 mux using case statement, okay. So what is the key difference from if else will become here? The case is more readable, okay. See here, you can easily get to read that. If 2 bit 00 means it somewhat looks like truth table only, right? But here you are using if elif else if else statement. But look here, it just somewhat looks like truth table only, right? So using if else, other than case, it will become like your code will become somewhat hard to read, okay. It looks like some you have written some complex code, okay. So just to make like code to look easy, we are going to use case statement, okay. So next, what you test bench, okay. Next we are going with the test bench, okay. To create a test bench, we are going to create a module, and to give a variable to name that module. And after naming, you need to create like import that components of that module, like what will be the input, what are the output, and where. Look here always in a test bench you are going to use wire as like output as wire, whether input as reg, okay. I will explain why we are going to do like this, okay. So after that you are going to import that hardware design name, and you are going to build a UUT. UUT means unit under test. Okay, what is going to do this unit under test? It's going to instantiate. Okay, instantiate means initialize. Okay, initialize means it's going to compare, like it's mapping, format mapping means it's going to map input I0 to of a test bench module to input I0 of waveform. Okay, sorry, design code. Okay, so it's going to initialize, okay, initialize what it's going to initialize, it's going to initialize design component to test bench components. Okay, so afterwards we are going to use the initial begins to begin the code, like a test code. After that, this dump file is used to create a ep wave, right? So the dump wares are used to create a levels in that ep code. Okay, so what does this mean? So I00 means uh, like just to read the code. Okay, so if you see ep wave, okay, ep wave, what does it values have? 0 1, right? It ep wave only has 0 1 values, right? So you are going to provide uh, 0 for all your even components, okay, even binary values, and 1 to all your decimal values. Okay, just to read in the design waveform. If you give I0, like just leave like that only means you can't get what is passing inside the that I0, I1, I2, I3. So just to read that, you're going to define I1 and I2, I3 with some values. So just to like this is general form, you are going to define all your even decimal values with 0, all with 1 with all for all odd decimal values. Okay, so for cell 2 bit 00, what you are going to get? I1, right? I0. But in waveform, you can't see I0. Like, how are you going to draw a waveform for I0? So, waveform is always in the form of 0 1, right? For 0, it will be like flat, and for 1, it's going to rise like this, right? So, just to read that, you are going to set the values. So, you can think that, oh, yeah, like if our uh, input is like for select line is 0 0 2 bit 0 0, then our output is getting 0 0 means I0. Okay, you can think like that. Okay, just for that purpose you are going to set some values for 4 is to 1. Okay, and like display means test done. Okay, after displaying that, I did something mentioned, right? Oh, that difference between display and finish in a previous class. Did you guys uh, check what is the difference between display and finish? Okay, I will explain. Look here. Display means it's used to display some text. Okay, display some outputs. Okay. So whereas finish means finish is going to do. It's like it's a, oh yeah, I finished the code. So just to say that, yeah, done. I have finished with my code. It's like ending that code. Okay, ending the test bench form. Ending to end the test bench form, you're going to use finish, or to display some text code, you are going to use display, or to like to monitor the code, like in which step what is going on. Like yesterday in previous class we used the monitor, right? Dollar monitor time for time you are mentioned percentage 0 t, right? To like to track that input and time, we are going to use monitor. So did you guys get the difference between display, finish, and monitor? So you guys got that. So after mentioning like this, you are going to end that module, what is bench module. Then you are going to like check for errors, and your simulation will be done, right? So this is with 4 is to 1. Okay, so just I did mention about something called reg, right? So I forgot to mention it. See, why we are mentioning reg in design code. Okay, just look. Now you have a multiplexer. Okay, so for multiplexer, you are passing a, okay, this is your design of your 4 is to 1 multiplexer. So here you are passing a inputs. Okay, what you have here for inputs, you have wire, right? Why you need wire? Because this input is coming from some other components. Okay, in your circuit this input is coming from other components. Okay, so if you give wire means that output from other components is traveling to this 4 is to 1 mux. So what does then it's creating that connection. What does wire do? Wire means it's build a physical connection. It's like it takes the output from one component to other component, right? So that's why you are mentioning wire in design code. Okay, so after that you are mentioning wire code, like wire for inputs, it will create a design. So then you are mentioning y, right? Y output reg y, right? So y reg for wire. Look here. See here. Now think you have built a design code. Okay, you have built a design code and you have mentioned input as wire. Okay, that's to carry input from other components to this 4 is to 1 mux, and you have mentioned y as reg, right? So I will explain what is going on inside that 4 is to 1 multiplexer. Listen carefully, okay? So think that input is coming from other components to this 4 into 1 mux, and inside that mux, it's going to test whether that component is like that input is what for that input what we are going to produce the output, like it will test like that, right? For if your input is 0 0, okay, if input is I1, so your select line is producing something, okay. Think as 0 0, your select line is producing 0 0. Then for 0 0, what will be the output? You should think, right? Inside that 4 is to 1 multiplexer, for these select lines what should be the output? So okay, so for thinking that, you are writing something called as this assignment statements. If our select lines as 0 0 input means I0 is y is equal to I0. So to store this value inside that y value, okay, inside that output we need to store something I0, right? For select line 0 0, to store that y value, you are giving here y as reg, okay. To store that input value inside that output, we are going to give reg, okay. So why do we need to store? Look here, think now you are 4 is to 1 getting input from one device, that is I0. What is happening is multiplexer, your multiplexer is getting input I0 from some other device, okay. So now in your y output, it's going to store I0 as a your input, okay. That is what is transmitting the I0 is now passing through your multiplexer, but suddenly your uh, some other important signal is coming, okay. Some other important signal is coming to your multiplexer, okay. Think that is as I2, okay. Now your select lines need to change to what? To 0 1, okay. Now your select lines to needs to change to 0 1, okay, to produce that input, okay. So to cut that signal before producing y is equal to I1, before producing signal I2, okay, signal I2, it should make to cut that connection of with I0, right? Because first I0 was passing through the multiplexer, so y was I0. Now you are getting some other signal like I2, so you need to cut that connection so that your y will become I2. So while cutting that connection, will like you need some time, right, to that cut that connection and to pass other connection. So in that meantime, you will cut that connection, but if you give wire as a y, okay. So if the cut connection means it will automatically cut. Why? Because wire, what is the ability of a wire? It's to transmit one signal to another, like it's acting as a physical connection, okay. So if you cut I1 I0 means input I0 means it will automatically cut y is equal to y will becomes 0, it will not show anything, okay. So if you mention reg as y, okay, reg as a y, it will think that even after you are cutting that input I0, it will think that, oh, it is still sending I0 as a condition, okay. So there will be no time waste. Okay, there will be no time lapse. After you are inserting some other input value, then that value will going to store inside this reg y. Then your connection will transmit I2. Okay, so this is why you are going to use reg inside your design block. Okay, just to store that input value. Okay, like if you're exchanging another input for I3, so you will waste that time, right, for cutting that connection. So just to make sure that your circuits work efficiently, you are going to use reg as y. So this is what the importance of reg while you are designing a hardware block. Okay, so just like common mistakes, forgetting reg for input in always block. This will be the common mistakes you're going to do while writing some code. Okay, so missing default case in okay, invert latch. Okay, it's create a latch. I will explain latch in upcoming class. Okay, don't think about latch. Okay, just think if you miss some default class, default using cases, it's create a latch. Okay, and like using 1 bit 0 when you need 2 bit. Okay, it create errors like this. Okay, just think about this. Okay, these are the common mistakes. Just avoid these mistakes. Okay, just to make sure like you know what are the mistakes that beginners do in verilog. To understand you guys, like to know these mistakes, I just had made a slide for the separate mistakes. Okay, and next we are going to 8 is to 1 mux. So if you guys like know everything about 2 is to 1 mux and 4 is to 1 mux means 8 is to 1 mux will be easy. Okay, just we can cover this 8 is to 1 mux in 10 minutes. Okay, so we can wind up our class. Okay, so look here, 8 is to 1 mux means 8 inputs 1 output. Okay, so what will become 2 power n, then how much select lines are there? So how this 8 occurs? Okay, how to get this 8? Yesterday I mentioned something like this, right? 8 to equate this equation, what will be the n value? Like what is the 2 power 0 value? 2 power 0 value is 1. 2 power 1, 2. 2 power 2 square 2 power 2, 4. Then 2 power 3, it will be 8, right? So if you have 8 inputs, then what is the n value becomes 3, right? Why? Because 2 power 3 is equal to 8, right? So this what is the like equation that is equating your input and select lines. So by this you guys are going to find out how many select lines are there, or how many, if you know select lines means you can find out how many inputs are we are going to pass in that component. Okay, so just keep it one. Now we have n is equal to 3 means 3 select lines. Okay, what is the 3 select lines? S0, S1, S2. Okay, so inside the 3 light select lines, what will be like our two table looks like 0 0 0 0 0 0 1 0 0 0 1 0 0 1 1 and 1 0 0 1 0 1. Like this our two table looks like, right? Based on this select lines we are going to produce our output. All right, so for what I explained for 4 is to 1 mux, same logic is going to applicable for this, but we have three decimal binary values here. What will be the binary values of this? 0 0 0 will get 0, right? 0 0 1 means 1 only. 0 1 0 means 2. 0 1 1 means 3. I hope everyone knows that decimal values. Okay, it just look like this. 2 power 3, 2 power 2, 2 power 1 and 2 power 0. Okay, 2 power 0 3 means 8, right? 2 power 2 means 4. 2 power 1 means 2. 2 power 0 means 1, right? So this will be the our decimal values looks like. So see here. Now you have consider this as S2, S1, S0. So now you have both the like all three value select lines values are 0 0 0. So S2 also 0, S1 also 0, S0 also 0. So you're going to get 0. Now we have one value as like S1 value is 0, S2 value is 0, and S0 value is 1. Okay. So S2 value is 0, S1 value is 0, S1 value is 1. So what will be the output? What you are going to get? Where is the 1 here right now? Is under S0, right? So what is the value of S0? S0 value is 1, right? Like that, how you are going to get output. Okay. Now you have 1 under S1, right? So 1 under S1 means 2. Okay. You are going to get 2 as the output. S1 1, S0 1, S1 1, S0 1. What we have S1 1 under 2, S0 have 1, 1 plus 2, 3. Like that only how this addition, like this binary values works. That are like this is how you are going to calculate the value of that binary digits. Okay. I hope everyone will know that concept. Just to make that reminder, like some of them have still have confusion. Means to clear the confusion, I just mentioned that. Okay. So this is how truth tables looks like. So this is the Boolean equation. Okay. Just try to calculate this Boolean equation on your own. Okay. Like today I'm cleared with 4 is to 1, right? Okay. So just to make sure that here, look here. If you guys get confusion, why is this S2 is outside this whole bracket? Okay, even you can write inside this bracket. Okay, because look at the truth table. What is this S2 saying? For first starting four values. Okay, for starting four values, it is showing 0, right? So every S value will be 0. First this value, this value, this value, this value. So to simplify that equation, we have just have taken common from these first four components. Like that only for next four values, S2 value is 1 1 1, right? So to simplify that, we have taken S2 as common from this. Okay, or else you can write like this only. S2 and operation S1 and operation S0 and operation S1 plus S2 and operation S1 and operation S0 and operation S1. Like that only you can write, but it will become like you need to write S2 value for every other values inside this. Okay. So just to simplify that equation, you are going to write Boolean equation here only. Just remember this Boolean equation is created based on the truth table. Okay. To satisfy the truth table, you need to create a Boolean equation. So this Boolean equation can be used inside the code. Okay, just that's how you're going to calculate like designing hardware. Okay, so try this. Okay, I will going to give a task. Okay, just try. Okay, build 8 is to 1 multiplexer using 4 is to 1 mux plus 1 is 2 is to 1 mux, and also build 8 is to 1 mux using all 2 is to 1 mux. So there will be in first step there will be 4 2 is to 1 mux. In second step there will be 2 1 is to mux, and after that there will be nothing, right? So 4 here you are going to get 2 here. From that 2 we are going to get 2 output. Yeah, total how many multiplexer are there going to be? 4, 2, 1. Okay, 2 is to 1 multiplexer becomes 7 2 is to 1 multiplexer. Okay, just try that. Okay, try and track the output. Okay, so very large code using assign. Okay, just like what in previous class said, right? Module to create a hardware block and give a variable name, and inside while designing you need to mention what are the components you are using, like prescription what I said, like what are you going to use inside the hardware block, like that. See here, now I've used same style, like 7 is to 0. This means 8 bit, 8 data inputs or 8 bit. Okay, for like now same like 3 bit select lines. Okay, for 3 bit you are going to mention 2 is to 0. For 4 bit 3 is to 0. Output wire y. I have mentioned wire y, right? Why I have mentioned wire y here? Because we are not using always block here. While using assign block, assign statement, you won't use always block. Okay, you are just assigning the values. So while what is assigning means, it's just transmitting what it's going to produce, right? So whenever you use always block, that time you need to mention output reg. Okay, for y, for output y you are going to mention reg. Okay, see here, you are using case statement, right? Input wires, output wires, and this will be the reg. Okay, so now you have mentioned reg, and this will be the just for truth table, that three bit, like 3030 means I1, I0, 001 means I1, like this all you're going to create a case statement. And like that only how you are going to create for 2 is to 1 and 4 is to 1 mux, just like that only you are going to create a if else statement for 8 is to 1 also. Just try if else case on your own. Okay, and the test bench, coming to the test bench of 8 is to 1 mux. Okay, you are going to create a module for that test bench and going to take that uh, components. Okay, while mentioning in the test bench, input should be in reg, wire should be, output should be wire. Okay, so after that you are creating a UUT. UUT means unit under test. What is going to do, it's going to initialize. Okay, instantiate the test bench code components to design, design code components to test bench code components. Okay, so after that, beginning dump file means it's going to create a waveform dump file, like that waveform name is mux 8. Okay, and the dump as means it's going to create a levels. Okay, 0 means 0th level. We are going to agree. 1 means 1th level. Okay, I will explain this level system in upcoming classes. Okay, so just keep that in mind, that this dump where going to create a levels in the code. Okay, in the waveform. Okay, after that, like you are going to, if a cell is 3D one. Okay, see here, here you have used decimal by b means binary. Binary value, b means binary, right? So you need to mention every binary values. Okay, 000. Okay, but here you have used another method. Okay, 3D means decimal values. Decimal values means 0, 1, 2, 3, 4, like that. Okay, this is how you are going to work. And after that, like the same only, 7D means 111. Okay, what is the binary value of 7? Decimal 7 number 111, right? So instead of giving binary values, we are using decimal method. Okay, display means it's going to display, like instead of display you can also use monitor here, just to track. Other than like using monitor, we have just used another method called display. We are going to display. So select line 0, then y is equal to percentage b. Like percentage means it's going to say binary value. What will be the binary value of y? Then you are going to get expression like this expression. Okay, I will explain this how this works in dmux. Okay, this kind of method. Okay, so for today's class, this is enough. Yes.